Okay, so because we're inching closer to the end of the semester and tests, so I posted the key to the homework. I hope that makes sense to you. I'm gonna say if you need more practice on page 57 and 58, you can only guess what these QR codes are gonna take you to. It's gonna take you to a video if you're stuck, right? So if you need more practice, 57 and 58 is gonna walk you through it. It's gonna go from writing the inequalities to doing all the work to graphing, right? So if you need more help, that's where you're gonna go. We're gonna go to that last, notice it says no objective function. All of these have no objective function. That's that one extra layer that we're gonna talk about today. So I want you to go to 59. So this is kind of like the last new thing that I'm going to talk about. And then everything else is basically you just have to practice and come across some of these scenarios that I may not have covered. Okay. So we call these types, when we add that extra layer, we call them optimization questions. And what I want you to think of when it's optimization is finding, right, the ultimate answer. You want to find the ultimate answer, and you need an objective function for that. Okay. So far, we just identified the solution regions or the solution polygons, and we found the POI surrounding the solution region. But now we're going to find the best answer. We're going to find the best answer, and it's going to come out of the POIs. That's where we're going to focus in on. Okay? So the optimal solution / the best answer, to get that, we need that objective function. I'm going to switch colors here. We need the objective function. Plugging the POIs into the objective function will allow us to determine the best combination. Okay, so plugging in the POIs into the objective will give us the best combination there, the optimal solution. I'm saying the same thing in multiple ways. The objective function, however, is not an inequality and should not be graphed. Okay, some students try to graph the objective function. It's a function. It's not an inequality. Okay. So, you're with me, right? This is very important that you grasp this last little piece. Because sometimes students leave this blank because it's more towards the end and we didn't have a whole lot of time to focus on it. But let's say you're given the objective function that looks like this, not an inequality. Let's say you already did all the work, you graphed it, you shaded it, you're determining that this is your solution region, and you've got 3 points of intersection surrounding it. The objective function will allow you to find the best answer in this case. So determine the optimal solution that would maximize, that's A, output or minimize output. We're going to figure out which one of these gives us the maximum, which one gives us the minimum. So let's do it as follows. So I'm going to say over here, 7, 6. I know, I should have done it the other way. I didn't know better back then. 3 times x minus 2 times y. That's 21 minus 12. And that is 9. Can you see that? So this point right here, right, I state the point of intersection, I plug it into the objective function, and I get 9. Okay? Then I have the next one is 7, negative 9. See, that's 3 times 7 minus 2 times negative 9. That would give me 21 plus 18. 21 plus 18. 59, right? That would be 39. Oops.
Excuse the interruption. The hold and secure has been lifted. The hold and secure has been lifted.
Okay, 7, negative 9, we get 39. Let's do this last one. 28, negative 9. We plug that into our objective function. It's 3 times 28 minus 2 times negative 9. Okay. That ends up being 102. So you do that. So the question may ask you for maximum, right? Maximum at, you would say 28, negative 9. B, the minimum is at, which one gave us the lowest output? It would be 7, 6, right? So you get 7, 6. So this is the last layer, guys. We're going to get these points of intersections from our graph. And the last step is going to be plugging it into some sort of objective function. Okay? So this, by the way, this is the objective function. Please don't graph it. Like some students like, oh, there's an X and a Y and a letter. Let's try it, right? Don't graph it. It's not what the objective function is for. Let's try one. From start to finish. Let's go to page 61. Okay? You still need, Leila? Need to copy this? Yeah, you're good? No, you're going to have to write it. Sometimes I give it in certain scenarios, sometimes you have to write it. We'll practice that in this scenario that you're about to encounter. So basically what I'm telling you is from now on, expect there to be some sort of optimization to have the full picture. That's kind of what we were aiming for anyways. So it's going to be a longer one, okay? So interruptions, that's not what I didn't account for that. A parking lot has an area of 540 square feet of space available. A car needs 9 square feet, a bus needs 36 square feet. The manager of the lot does not want more than 45 vehicles on the lot at the time. Continuing, it says a lot has a minimum of 10 cars per day since there are people working close by. State the variables, implicit constraints, write inequalities. And then it says C, this one here, determine the combination of cars and buses that would maximize profits. When you see that, maximize or minimize, it means that you're going to need an objective function, that this statement most likely is going to help you determine it. And I'm going to show you how to do that once we're done the rest. So let's talk about the area available. This is almost like money available. You have a budget of, right? This is IQ number 1. You have to have an inequality that deals with the space available. Then there's IQ number 2 right here, that only 45 vehicles on the lot at a time. So you got to account for that. We're going to have to come up with a restriction for it. And then another one is a minimum of 10 cars per day, since there are people that work close by. So this is IQ number 3. Okay. So let's write our state our variables. X would be, what do you think? X would, what would we let X be in this scenario? Usually cars, yeah, number of cars. And Y, buses. And X and Y would have to be greater than or equal to 0. Squeeze that in somewhere every time, and then you don't have to think about it. B, write the inequalities. Let's do them. What I will do is to give ourselves space, guys. I'm going to put the first one here, the second one in the middle, and the third one out to the side so we can do work right underneath them. So the first one talks about space. So I'll say 9 square feet for a car, 36 square feet for a bus, and that, like whatever many cars and buses are in there, I have to just make sure that it's less than or equal to 540 square feet. I'm going to kind of cut it off here already to indicate, you know what, I'm going to do the work there. The next one is no more than 45 vehicles combined. It's just the vehicles themselves combined has to be less than or equal to 45. Cut that off. And then the last one is a minimum of 10 cars per day since there are people working close by. This one is specific to cars only. So it's X is greater than or equal to 10, a minimum of. So we're assuming that we need to graph. Let's do the work here. So X and Y intercepts. Okay, I'm just going to break this down like this. 9X is equal to 540. X is equal to 60. So 60, 0. 36, Y is equal to 540. This shouldn't take you too long anymore. Oh, sorry, 15. 0, 15. Rewrite. This is good. I will say that this is a solid line. The true region in this case would be below the line. I will shade above. Make sure you circle that. Next one. This is just X is equal to 45, so 45, 0, and Y is equal to 45, so it's 0, 45. Rewriting it. Solid line. You probably realize that most questions, maybe you've come across one that hasn't been, but it's solid. The true region is below the line because it's less than, and we will shade above. Vertical. Vertical line at 10, 0. Solid. True region is above the line. Sorry, this is a vertical. Careful. True is to the right. Shade to the left. No need to clean up, no need to do anything, that's just all you need there. Now we graph. So grab a ruler. We have everything we need to do a nice graph. I'm just going to zoom out here. And I think I'm going to do the graph right here because I have a bit more space so that I have a bit of room left here. So let's see here. I have, this would be number of buses. This would be number of cars. And we have, let's look at our numbers for the X. It's 60, 45, and 10. So 60 will do. So 10, 20, 30, 40, 50, 60, 70, 80. I'm going to go to 80. So 10, 20, 30, 40, 50, 60, 70, 80. That's good. In terms of the Y, the highest I get to is 45. So I'm going to go 10, 20, 30, 40, 50. I will only label every other one. That's perfectly acceptable because you're consistent. Let me just focus here. First line, 60, 0, 0, 15, right about there. Another one is 0, 45, 45, 0. This one is x plus y is less than or equal to 45. And then the 10 line is just a vertical. And now it's just shading time. So it's above, I'm above this line. I am above this line, which gets rid of this little sliver. So at first you think there's nothing, no relevance for it, but it does. It kind of gets rid of that little sliver mostly. And then the vertical I shade to the left. So we go here. So it gets rid of that little corner there. And now I'm left with my solution region. This is kind of what we've been doing up until this point. This is technically all part of B here. We wrote our inequalities, we rewrote them. We did a bunch of work so we could actually graph it. So we know that our solutions are found in here in this polygon. But the next item is to make sure you find all of these points of intersections. So POIs, we can read these two here. We know what they are. So don't use your calculator for something that you know. 10, 0 and 0, 45. So that leaves us with having to find these two here. Okay, so grab your calculators. I want you to remember how to do this. You want to type them all in. Okay, so -9 divided by 36x plus 15 negative x plus 45. And remember this one, 9 nines. And then it's x minus 10. And remember your window, you kind of want to replicate what you have here. So my x max for my graph is 80. My y max in here is 60. And so there you have your graphs. And we want those 2 points right there. Between the red and the blue, let's find that one first. I'm on the blue, hit enter. I'm on the red, hit enter. Enter one more time. 40 and 5. Okay. Then this one over here, second trace 5. Between the blue and the black, so I'm going to go along the blue. You don't really have to, just select any point on the blue, cycle through till you get to the black line, hit enter, enter. There we go, 10, 12.5 is this one right here. One extra step here, when you have decimals and it's discrete data, we will go 1013 or 1012. It's up to you, but we round it to a whole number. You might say that 1012 because then you're below. If you go 13 and you're going to be above it, that's you have a point, but make sure it's a whole number if it's discrete. You know where I store all my dad jokes over the summer? In the Dada Bank. Anyways, very cheesy, very cheesy. I couldn't help it. So, okay, now I'm going to pause here for a bit and then we're going to come back to this one. See that blank page on the next, on 62? We're going to go there for a little bit and practice writing objective functions. And let's see if you grasp that concept. Let's go to 62. So I'm going to call this writing objective functions. Hopefully after this you're going to be a pro at writing objective functions. It should always look like this. A classic example would be m is equal 4x plus something y. Okay, that's going to be the classic look of it. So write the objective function. I'm going to call this OF. Okay, that determines the amount of space occupied or utilized. Same thing. And I will do the first one for you. No, I don't think so. I checked. It was supposed to be on the 12th.
But the accent at the start, taking
Oh.
I'm doing
I know. I was thinking.
No,
of
I'm
it.
so
All right. Space. I use the letter usually that goes with it. This space utilized at any given point is going to be, how much does a car need? 9x plus 36 for a bus. That's it. This would be the objective function that tells you how much space is being used up at any given point on our graph, guys, right? So if you have like 10 cars and 10 buses, it'd be 90 plus 360, right? You add that up, that's how much space is now being used up. So that is what we call the objective function. That's the one that allows you to figure out how much space is being used up. I could say write the objective function that determines, let's shorten this, the number of cars, or vehicles, sorry. We got to be specific here, vehicles. What would be the objective function that would tell us how many cars are in the parking lot at any given time? I will say this, vehicles would simply be X plus Y, right? If you were to add up X and Y, then you know how many vehicles are in that parking lot at any given time. That's all I can do in this case. We don't have more information. If they talked about how much each car pays, and we want to know how much money can be earned at any given time, we would go earnings, maybe E, the dollar amount per car, the dollar amount per bus, okay? So that's kind of like the pattern here. So now we go back to our question. C asks for, what does C ask for? Let's read it. Can you go back and read it? Determine the combination of cars and buses that would maximize profits given that a car pays $7.50 and a bus pays $25. How would you write your objective function there? I'm going to take the liberty to say P for profit. 750x plus 25y. There we go. You've got your objective function. This one allows you to figure out how much can I charge to maximize my, like how can I maximize the income that I make as the parking lot manager? I don't think there is such a thing, but hey, if there were a parking lot manager, this is how they would do it. So we need to take all of our POIs, 10, 0, plug it in. 750 times 10 plus 25 times 0. Why would you do that, Mr. Erickson? That's such a waste of time. I know, I agree. The 0, right? Why? That's 75 bucks. If you plugged in 0.45, like that option where you have 0 cars and 45 buses, plug that in, 750 times 0 plus 25 times 45. You can do this on your calculator. Did I get that wrong, guys? My eraser is like gonna disappear by the end of this lesson. You caught it, right? Can I ask you to go back to 61? I blame all the interruptions today. That's what I blame this on. This was not 0.45, this was 45.0. You knew that, right? You just didn't tell me. 45.0. My bad. So we come back here and we change this to 45.0. No problem. Just some scribbling and some crossing off. And next thing you know, we're on track. This is going to give us $337.50. Then we've got the 40,5, 750 times 40 plus 25 times 5. You plug this into your calculator as is, you get $425 out of that combination. And then the last one is 1013. 750 times 10 plus 25 times 13. If you do this, you get $400 even. Bless you. And you're not done. Just when you think you're done, you're not done yet. we can tell that we make the most money in this scenario right here. When we have 40 cars and 5 buses parking. And this is considering all the restrictions we have, right? So we will say this. The maximum profit at 40, 5, 40 cars and 5 buses. Just make sure you specify, and you can have probably a nicer statement. I'm just running out of time here. But it's 40 cars and 5 buses. That's what that represents. Max profit of $425. That's per day. And that, ladies and gentlemen, that is the last part. This part we just did right here. C. Okay? To come up with the objective function and then test it against the corner points. Sometimes you have 3, sometimes you have, right? Like, depends on the situation. And then you determine either the max or the min. It could be that the question asks what's like which combination will give me will be the situation where I spend the least amount of money. Then you would obviously look for the lowest output. Okay. Is that all I have to say? I think so. So I'm going to ask you to try. Hold on, I don't want to do the pizza one yet because I'm too hungry to deal with that one. I'm going to send you to 67 and 68. 67, 68. There we go. That'll do it for you. I will post more pages, so if you feel like you want to do more, like I told you that 58 and 59, for example, 57 and 58 have videos. So if you want to, these are optimization questions. These are optimization types of questions, okay? 2 questions.